In this class, we're going to see the nodal analysis. So, in order to analyze the network, we need to go for the different techniques here. It is called the nodal analysis and mesh analysis we have. So, before going to go through the detail of the nodal analysis, I need to understand what is a network analysis. What is network analysis here? Suppose I have a network. Very simple series circuit. If I have some series circuit, and any series circuit, we have voltage, resistance, and R1 and R2 is there. If I'm able to find what is the voltage, current, and power at each and every element, then I can say that this network is analyzed. Suppose if I'm able to find what is the voltage here, current here, and power. Similarly, here also if I find what is the voltage, current, and power, and similarly here with the same thing, voltage already is there, current, and are able to find power. At each and every element we have required to find all these parameters. So with this will come to get the idea is that we can detailed analysis can be done. So net analysis is, so you need to find the all the quantities at each and every element, then that process is called the network analysis. So if I take a very simple circuit like this, it is like this, and if I give the 10 volts source, and this is my 2 ohm and this is my 3 ohm resistor is there, and if I ask you to find what is the voltage, current, and power at each and every element, you can do it. You can easily do that one. Okay, so I can say this is the current is flowing. I can be written as 10 by 5. So this is 2 amperes current is flowing, 2 amperes, and here also I can write the 2 amperes current is flowing. Now same current is coming here, it is the 2 amperes current in this source also. Now what is the voltage here? Voltage across this I can write this voltage here. So I can take this is that 4 volts, and here it is 6 volts. So this is a very simple circuit. For this circuit I applied, so I only apply the Ohm's law, and I'm able to find what is voltage, current at each and every element, current and voltage at each and every element. Once we'll get these values, parameters, so you can write what is the power at this one, what is the power at this one, and you also can write what is the power that power supplying this source. So those kind of analysis can be done. Suppose if I increase the complexity of this circuit, if I increase the complexity of the circuit, something like this, and you have again some current source like this, and this is what the circuit now I have, something like this. You take some values, it doesn't matter here, some 5 amperes and 2 volts now. Now for this circuit I need to analyze my what is the voltage here, current, and each and every element. That is what I need to do here now. So in order to, what is the voltage here, current here, what is the voltage and current, what is that current and voltage, something like that at each and every element I need to find. So current something like this, and also I can find the power at each and every element. So this is a very complex network I am consider. So I cannot but by only applying that Ohm's law or KCL and KVL, it is very difficult to solve this kind of networks. It is very difficult to solve this kind of network. You try this one at home, and only by applying these laws, we try to find what is the voltage at each and every element, currents and powers at this particular network. So this is a little complex. It is not come the solution very easy. So in order to do the network analysis of such complex networks, to do the network analysis to such complex networks, so we have the two different methods have called the nodal analysis, and is called your loop analysis, or you can call it mesh analysis. So this class will deal with that nodal analysis, this class. But before that, we'll see some what are the possible difference between nodal analysis and loop mesh analysis here. So this nodal analysis can be done. It is the combination of your Ohm's law and KCL. This is the combination of Ohm's law and KCL. But this loop analysis is the combination of Ohm's law plus KVL, Kirchhoff's voltage law. And the application of this nodal analysis will more effective or easily can solve the networks if they have more number of parallel paths, and if you found more number of current source, then if you apply this technique, then you can easily solve the network. So this is need to remember here. Simply we are going to applying Ohm's law, combination of Ohm's law and KVL is going to do your nodal analysis, and to which kind of network you are actually going to apply this nodal analysis is if you by seeing the network, if you find that more number of parallel paths is there and if more number of current sources are available in that given network, then you directly can go for the nodal analysis. Now comes to this loop analysis. So this is the combination. If you take the Ohm's law and KVL combination, then that is the loop analysis. And this loop analysis we are going to do on the if you have the more number of series elements, and if the more number of voltage sources are available, then we're going to use this loop analysis or mesh analysis to solve the any kind of network. If you take this network, for this network, I can use the nodal analysis, I can use the loop analysis, I can find whatever the voltage, current and each and every element that can be done by using these two elements. But the thing is that which method is more appropriately going to give very simple solution, that is we need to know here. So which we will go for nodal analysis or we go for loop analysis. So that is depends on our common sense. But with the two methods also, this network can be solved. So that is the point you need to remember. Now we will see what is actually the nodal analysis. So how to analyze any given network in order to find the voltage, currents and each and every element of the network. So to that you are going to take the steps here, procedural steps, how to follow this one. The first step what we are going to do is for the given network, identify identify the number of nodes including reference node. So this is the first step we need to do. The second step is, now after finding the nodes, assign the node voltages and mark the current direction. So very simple language, I'm giving the procedure how to solve the any network by using the nodal analysis. So after mark that current direction, third is apply the KCL at each node. And write the equation. So that is the third step we're going to follow. Then finally, so after getting all the equations at each node, so after getting all the equations at each node, solve those equations will gives the solution. So that is what the 4 steps you need to follow to do the nodal analysis here. So here you need to take one note here, what is meant by node and junction here. So the node can be written as, if the three or more elements join together, then that point is called a junction or node. Then that point is called node or junction. So that is the point you need to remember in order to identify how many number of nodes we have, including reference node. So now comes to here, for this network, you come back to this network and see here. So I need to identify what are the nodes I have. So 3 or more elements at this particular point I can find, and 3 or more elements at this particular point I can find, and I can write, this is the node 1. At this node 1, this is the voltage VA and this is the voltage VB I assigning. So these two nodes, this VA and VB, the point 1 and point 2, the 1 comma 2 are called non-reference nodes. Reference nodes here. That what is the reference node here? Reference node, or you can say the grounded of the circuit, is called this is called the reference node. And this reference node is, as usually the potential of this grounded part is, you can say, 0 volts, and this reference node can be taken as the number 0. So 0, 1 and 2, 3. So 0, 1 and 2 are the name has been given here, and 3 nodes are identified in this given circuit. In that, this is the reference node, and 1 or 2 are called the non-reference node. So this is the part I identified. So once you identify the nodes here, so you need to mark the current direction from this particular points. From these points, you need to mark the current direction. So that is according to your wish, we have to do that one. So what I'm assuming, this my current direction in this and this, according to this point, my current direction I am taking, this is my current direction I am assuming in this way, and my current direction is also assuming in this way. It means that my current is going away from this node. So that is what I am assuming here. So this is my current direction with respect to the first node. These are the current direction I am assuming. So that assumption completely based on you have to identify, you have to assume that all the currents are away from the node, or all the currents are going inside the node. So whatever the convention you follow as your wish, for for my sense I follows always from this point my current is going in away. So that is the my convention I usually follow. Now after this again come back to the second point here. For this second point again I need to again mark the current direction with respect to the second point, second node. Again I need to mark the current direction with respect to the second node here. So this is the my current direction with respect to second node. So this is my current direction with respect to second node. I assumed it. This is the my assumption now. So this point is over. This is done now, and this is also done now. Now apply the KCL at each node and write the equation. So that is what the third point is going to give some information to us. So let us consider the node 1. At each node we need to apply the KCL. Let us consider the node 1 and apply the KCL here. Apply the KCL. So apply the KCL here. So what is the current flowing in this? So this is my current direction. So what is the current flowing in this direction? So the difference between these two potential, VA minus V1 by R1, can I write? What is my potential going here? I can write VA minus V1 by R1. So this is the first current, isn't it? VA minus, this is voltage by resistance, that is current. This current I am writing in this direction. In this direction, this is the current I am writing. So VA minus V1 by R1. Why I am taking minus here? Because according to my current direction, this actual source is plus and minus, so this is opposing this one. So actually according to this source, plus and minus means this is the current direction actually according to this source, but my assumption is going according to this one in opposite direction. So that's why I'm taking VA minus sign here, V1 by R1. So this is what I'm writing for the first current in this branch I'm writing. Now come to write for this branch. What we're going to write? I can write plus VA minus, what is the voltage at this point? What is the voltage at this point? 0. 0 by R2. R2. This is also one current plus. Now I want to write what is this current? This direction is going current. I need to write. So I can write VA minus VB, VA minus VB by R3. R3 equal to 0. So this is what the KCL we are writing for this network. So why I am writing again minus here? Because with respect to this terminal, this node, my current direction is this, but actually with respect to this node, the current direction is coming like this. So these are the opposing to each other. So that's why I am getting that minus point, VA minus VB by R3. So equal to 0. This is the equation 1. So this is the equation 1. So this is nothing but, if you assume, this is nothing but say I1, I2 and I3 like that. If you assume, then I can write this is I1 plus I2 plus I3 equal to 0. So this is what the KCL the writing. So this is the current, this is also a current, and this is also a current equal to 0. So this is my KCL I'm writing here. So my expression is this. Now I'm going to take here that node point, node 2. Now I'm considering the node 2, and again I will writing the what is the equation here. So with respect to the node here, if you take this branch should take here, can I say it is nothing but VB minus V2 by R5? R5? Yes, because this voltage is actually opposing plus and minus, so it is opposing to my conventions. That's why it is coming minus plus. Now come to this one or this branch you take. I can take VB minus 0 by, because it is the zero potential here and in between these two voltage, this is R4 plus, what I'm going to write, this one again I3, with this current I need to write again. So these are the three currents, right? This current, if you write, what is this one? VB minus VA by R3 equal to 0. So this is the second equation we are going to take, right? So this is how we are going to write the KCL at each node. Once you identify the node, you need to write what is the KCL. Once you are getting the, so we have identified the two nodes, we are getting the two equations here, two nodes and the two equations we are getting. And if you solve these two equations, you are able to find what is VA and what is VB. This is can be calculated or can be find by solving these two equations. So this, how to solve this equation and that kind of things we're going to explain by taking the numerical values, and we'll do that later. This is what we need to understand the concept here. Now this is the question has been given to us, some numerical, and they are asking to find what is the voltages V and VB across these 2 points, and also asking to find what is the current I is flowing through this resistor. What is the current is flowing through this resistor? So this is what they are asking to do this one. So if you apply KVL, KCL and other kind of techniques also you can do it, but that is going to take more time, and it is quite complex. So better you take nodal analysis, that rules, and follow that. You can easily get that values here. So what I to do first, I have to identify the nodes here. So this is one node, so this is one node, and this is my reference node 0 volts. This is was done, and I also to mark the current directions in this direction, in this direction, in this direction. These are the directions I am marking the current directions. Now take at point A, at point A, at point A, apply the KCL. Apply the KCL now. What you are going to get? You take this branch. I can write VA minus 400 by 20 plus VA minus 0 by 80 plus, and again you can write here VA minus VB by 15 ohms equal to 0. This is one equation we are getting. Now come to that second point here. At point B, again apply the KCL here. Apply the KCL, and you can take VB minus VB minus 200 by 10 plus VB minus 0 by 90 plus VB minus VA by 15 equal to 0. These are the two equations. So two equations, two unknowns. You have the two equations and the two unknown parameters, that is VA and VB, isn't it? If you solve these two equations, so these are the, after solving this equation, so you are going to get V1 and V2. Once we are getting the V1 here, so this is my V1 here. So this is VA, and we are getting 262 point something volt, and VB we are getting 209 point something volt. So these are the two voltage we are getting. So I need to find what is I across the 80 ohms. 80 ohms. Can you find this one? Because this voltage by this resistance, if you do this one, this current you can easily find. So I can write, we want to find what is I here in 80 ohm resistance. So 262.03 by this 80 ohms equal to, if you do this is what the value we are going to get. So this is like that. You can calculate here also current, you can calculate here also current, you can calculate here. So once you are getting this potential voltage at each and every point, you can find what is the current at each element. You can do it. Once you will do it current findings, and then you can calculate the power at each and every element. So this is what the nodal analysis is giving, a very simple solution to calculate any kind of parameters. Now we'll see some different configuration I am giving here to find some nodal analysis equations here. So let us consider the first one and identify the number of nodes here. So this is the node 1, you can take V1, and here, so this is combinedly as a V2, you can take and mark the current directions here. So this is my marking direction for current. So this is with respect to the second node, my current direction marking here. So I will take the point at V1 point. Now write the equation here. So this is my reference node here, again reference node, write the equation. Now can I take V1 minus 0 by R1. So this is I'm writing for this one. Now what about this branch here? Because here already the current source has been given here. So but the current source, that is value Ix, has been given to us, but the current direction of this Ix is actually opposite direction to my convention. So I can take this is minus Ix. So this is what the current, isn't it? This is also current, this is also current. So already the current source is there, current is giving are known to us, and but the direction what I assumption is and different from the current source direction. So that's why I'm writing minus Ix. Now plus, what is this? I have to write for this element current direction V1 minus V2 by R2 equal to 0. This is one equation. Same at point V2, do the same thing here. So this is my direction. I can write V2 minus V1 by R2. This is the first point I'm taking. Then go for the R3 plus V2 minus 0 by R3. Next for R4, right? V2 minus 0 by R4 plus, now come to for this branch, right? So this is my assumption current direction, but actually the voltage source current also going in the same direction. So I can make it as the plus here only, same direction. So plus Iy equal to 0. So this is my second equation. So this is how we are going to write the nodal analysis equation if you have the current sources which are quite, one is going opposing and one is quite in same direction. Then this is how we are going to write the equation. So once you will write this equation, you solve this equation, then whatever the parameters you want, you can find. So that is what. Now we'll find what is the VA and VB for this particular network. We will take this network and we'll find that one, so that you will have some idea how the numerical can be solved. Okay, with respect to this point, so these are the my current direction assumption for these three elements. And with respect to this point, these are the combining the node it is. So these are my current directions I'm assuming. Okay, and I need to find what is V and VB. So take this point now. First point, we take the first point. Now first point and write the equation. VA, this is the 0 reference voltage, so VA minus 0 by 5. What about this one? This is minus 2 amperes, right? Because it is going in opposite direction to my actual convention direction. So minus 2 and plus VA minus VB by 3 equal to 0. So this is the equation 1. Now take the second point. Now take the second point and write. This one you take and write. So this directions VB minus VA by 3 plus VB by 4 plus VB by 6. What about this current in this one? Here it is going quite opposite to each this two, right? So these are the minus 3 equal to 0. This is the second equation. Now see these two equations we have two unknowns. To solve these equations, you will going to get what is VA and what is VB, that is equal to these are the voltages at the points V and VB. So once you know these points, voltages, so you can easily find what is the current in each and every branch, and what is the power in each and every branch, and what is the voltage in each and every branch. So that kind of analysis can be done, right? Now, so this is the another scenario I'm providing to you to understand more effectively this nodal analysis. So this is one it is a combination of current sources and voltage sources are there. So take identify how many nodes we have here. So these are the two non-reference nodes, VA and VB. This is my 0 volt, so potential, so reference node this one. Now take the point that at node 1 apply the KCL and write. So mark the directions here. So these are the direction for this with respect to this point. With respect to this point, this is the directions. Is going like this. Okay. Take the first point here. So I can write VA. Whether I have to write minus or plus here. So that is the question here. So because at this moment my voltage source minus and plus, so according to this sign convention, this is the direction of current actually with respect to this source. So whatever the convention I assumed, that is also in the same direction, both are in the same direction. So I can take plus V1 by R1, so plus this one VA minus 0 by R2 plus VA minus VB by R3 equal to 0. This is equation 1. Now at node 2 again write the equation for this one. Now right here I can write VB minus VA by R3 plus now see here. So this is the current. I1 is the current is going in down direction. My sign that current marking direction also both are going in the same direction. I can take the plus I1, and here you see my current is flowing through this branch, series branch. These two are, so same current is flowing in the R4 and as well as this current source. So my current direction, actually current source direction in this direction, my assumption is quite opposite to that. So I can take that is the minus I2 equal to 0. So this is how we are going to write the nodal analysis. So these are the different configuration I have shown you, and I have also wrote the expression to how to calculate voltages, currents. So I think we have understood what is nodal analysis in detail. So different configuration we have seen, and how to write the equations we also seen, and you can take the numericals, different type of numericals, and you try to solve them. So you'll get some you can explore the knowledge, so that you will be a very confident level to solve any kind of networks. So here I just wanted to explain you a concept is called the supernode. So this topic, we are not going in detail what is supernode and how according with this supernode we are not going to do the problems. This is, but you need to understand what is the supernode. So that's the reason I'm giving the concept here. So let us so supernode is nothing but what, if the voltage source, if the you define this, if the voltage source is alone is connected in between, connected in between the two nodes, it is two non-reference nodes, between the two non-reference nodes, then it will form the supernode. So this is the statement you need to to understand this. I will tell you how to remember this one. Suppose I have a network like this. Suppose I have a network like this, different elements like this, and so and like this, something like this, and I have network like this. So this is what the network I'm considering here, and I assume I R1, R2, and R3 is there, R4, and assume some voltage. This has some V. So what is mean by supernode is, suppose this is my reference node here, but actually these are my non-reference node. 1 and 2 are the point, are the non-reference nodes. So what is the concept of supernode is, if the voltage source is connected in between the two non-reference nodes, so these are the two non-reference node, in between the two non-reference node, if this any voltage source is connected, then it is going to form a supernode. It is going to form a supernode. So that is the what the concept we need to understand. So I'm considering a network, something like this. Both have the same little bit. So in this, the two, this is my non-reference, this is reference node, and these are the two non-reference node. In between these two nodes, this is my network is connected, but here I want to find what is V1 and V2. Suppose this is the question is given to us and asking to find what is V1 and what is V2. Then by seeing this network, we come to know that, so one source has been connected in between the two non-reference nodes. So this is going to form the supernode. So that is we need to understand here. If the supernode is connected in between, if the any source has been connected in between V1 and V2, this is going to be different network. So this is we are going to do the supernode analysis. We are not going to do the normal nodal analysis. In the normal node analysis, this kind of voltage source may not be there in between the terminals. If this kind of network, if you are identified at any theoretical books, then you come to know that, so this is a supernode analysis. We need to do the supernode analysis in order to find what is V1 and V2. What is V1 and V2? So how are you going to do the supernode analysis here? So both our nodal analysis and these are both are almost same, but you need to remember an extra point. I will tell you how to do that one. Okay, according to the nodal analysis, we need to identify the V1 and V2. So this is the what we have done. Okay, V1 and V2 has been done. V1 and V2 has been done now. After that, I have to assign the current directions. So I'm assigning the current directions like this. For with respect to the second node also, I'm assigning the current directions like this. So once we will do this one, so what we are going to do, what we are going to assume here is that, so what I'm going to assume here is, so I will assume that this part is excluded from this network. I assume and I exclude this part. Assumption, you assume that this part has been excluded, and whatever the leftover is there, you have to take that network. So now this is the kind of network will coming right again. So here, something like this is coming. This is what the network: 10 ohms, 20 ohms, 40 ohms, 30 ohms, and 5 amperes. This is my VA and VB. So V1 and V2 is there. These are the current directions we have taken already, right? So after excluding that part, so this is what my network. Now I will write what is the equation for this point with respect to this node 1. What is the equation at the point 1 with the node 1? What is the equation you are getting? I can write this is the V1 minus 0 by 10 plus 5. This is one equation I'm getting. With respect to this point, what is the equation you are getting? With respect to this point, you can take this one. I can write V2 minus 0 by 2 plus V2 minus, these are the two are in series, so 30 into 20, 30 into 40. So this is, I can take as, this is what, this is 2 not 2, is 20. So 30 into what, it is 70 equal to 0. This is the second equation I'm getting according to nodal analysis. So after getting these two equations, you combine the equation 1 plus 2 and make it equal to 0. Combine the equation 1 and 2 and make it equal to 0. So now do that one. So I will get V1 by 0 by 10 plus 5 plus V2 minus 0 by 20 plus V2 minus 0 by 70 equal to 0. This is my equation 1, and I'm writing this is called equation 1, sorry, equation 3 you can take now. So this is what I'm writing in case of super node analysis. This part is I'm excluding, and whatever the leftover part for that, according to that nodal analysis, I'm writing the equation with respect to this point, with respect to this point, and I'm just combining those two equations. So this is the equation I'm getting. Now only consider this one now. Only consider this part now. Only consider this part. Then what could be the scenario for this one? If you consider that one, then this is my V1. This is my plus and minus 10 volts, and this is my V2. So this is what the leftover part we are going to take here. So after taking this, assume this is my zero reference. Now it is my zero reference, isn't it? Assume zero reference. With respect to zero reference, what is V1? V1 is plus, is minus. Here also it is plus and V1, something like this I can take. Now if you apply a KVL in this loop here, you can take, it is the direction. If you apply a KVL here in this direction, so what we are going to get here, you just see here, I can write this one minus V1 plus 10 plus V2 equal to 0. This is what I am writing. So this is also can be written as here V2 minus V1 is equal to minus 10, or V1 minus V2 equal to 10. So this is the fourth equation I'm going to get. Now these are the two equations we are getting now from the super node analysis. Two equations, equation 3 and equation 4 are the two equations we have, and again we have the two unknowns V1 and V2 we need to find. These are the two equations and the two unknowns we have, V1 and V2. Solve these two equations, then you are going to get V1 is equal to 1.695 volts and V2 is equal to going to get minus 8.304 volts. So this is how you are going to apply the super node in order to solve this kind of networks. Assume if you find any kind of voltage source in between the two non-reference nodes like this, so that time simple nodal analysis we cannot apply. For that we need to go for the super node analysis. In the super node analysis, what we have to do is, so where the super node point, that is where that voltage source is present, that should be identified, and that is excluded from that part, and remaining leftover part I am writing. After writing this leftover part, I am applying the nodal analysis that at this moment. At each point after applying the nodal analysis, we are getting the two equations, and these two equations we have to combine. We have to combine these two equations. So this is what we are going to get. So this is what the super node equation we are going to get. So this is what, once this equation we are getting, then going to consider this part again. So this is what we are considering, this part here again. And for this equation again I am writing the KVL concept, because this is one potential, this is one potential, and this is one potential. So three potential are there, and I am assuming it is some KVL concept here, and I am writing. So from that V1 and minus V2 is equal to 10. This is what we are getting. The equation 3 and equation 4, these are the two equations we have now. And for these two equation 3 and 4, two unknown V1 and V2 we need to find, and finally solve those two equations. We are going to get V1 and V2. So this is how we are going to do the super node analysis, and you can do this more number of problems on this super node, so that also you can get some idea. So I think you understood what is the nodal analysis and what is the super node concept, and how we are going to apply the super node concept to which specific networks. Those kind of knowledge I think you got. And so with this I will conclude this session for today. In the next class we're going to see so loop analysis, and we'll see that concept, and we'll do some numericals on that.